This is Nobel Prize type research. It is literally amazing, and the impact can be incredibly profound. A caveat number one, this is an animal model, meaning the study has to be replicated in carefully controlled human trials. But the methodology in the execution of or I should say the delivery of the main component ethanol in the research in this animal model was simple. I think in this case they used a humidifier, but however though, the outcome was so incredibly profound, it does not require a huge depth of the imagination to see how this could impact all of humanity in a very, very positive way. So with that in mind, let's go right into the research. And you're reading a major article up there from the Journal of Infectious Diseases, and that is no understatement. Why this was not picked up by other media outlets per se, I have no clue. But today, you and I will cover it, and because we're lucky enough to come across this article. To proceed as follows. Effective ethanol vapor inhalation treatment on lethal respiratory viral infection with Influenza A. Journal of Infectious Diseases. A warning before I proceed. There it is. Don't be silly. Now, this is their study in the public release. So I should say this is their wording. So it is that profound. But let us begin. Inhaled ethanol may treat respiratory infections and stop pandemics. Inhaling low concentrations of ethanol vapor can disable the influenza A virus in mice without harmful side effects, says a new study by scientists at Okinawa Institute of Science and Technology. The scientists believe may also treat similar viruses such as the one that causes, in their words, not mine. Now, we are going to go to the full study. We deal with individuals from many diverse backgrounds. So we want to validate the study first by going through the technical part. Then we'll come back to the end of the part, which is explained more in layman terms. To proceed, ethanol effectively inactivates envelope viruses in vitro, including influenza and severe acute respiratory syndrome coronavirus 2. Inhaled ethanol vapor may inhibit viral infection in mammalian respiratory tracts, but this has not yet been demonstrated. Here we report, obviously quoting, unexpectedly low ethanol concentrations in solution, approximately 20%, rapidly inactivate influenza A virus. You can see IAV quite often. That's influenza A virus at mammalian body temperatures and are not toxic to lung epithelial cells on apical exposure. Furthermore, brief exposure to 20% ethanol decreases progeny virus production in influenza A virus infected cells. Using an ethanol vapor exposure system that is expected to expose murine respiratory tract to 20% ethanol solution by gas-liquid equilibrium, quoting, we demonstrate that brief ethanol vapor inhalation twice a day protects mice from lethal influenza A virus respiratory infection by reducing viruses in the lungs without harmful side effects. Quoting, our data suggests that ethanol vapor inhalation may provide a versatile therapy against various respiratory viral infectious diseases. And that's going to be expanded on quite a bit. Now I'm going to go back to the public release article, and then we're going to jump back to the full study in a few seconds. Using a humidifier to produce ethanol vapor in a small container, they found that when mice infected with influenza A inhale the vapor for 10 minutes, the virus is inactivated. The study is published in the Journal of Infectious Diseases. The scientists think that the ethanol vapor must increase ethanol concentrations of fluid to 20% to successfully treat the infection. This concentration is not toxic to lung cells the scientists created in the lab to mimic human cells. At body temperature, 20% ethanol can not only inactivate the influenza A virus outside the cells in 1 minute. I'll reiterate that. At body temperature, 20% ethanol can not only inactivate the influenza A virus outside of the cells in 1 minute, but also stop the virus from replicating inside the cells. Influenza A is a virus that has an outer membrane called an envelope. Ethanol vapor may is the operative word here, also inactivate other envelope viruses such as Sars COV-2, quoting the professor. And so far, all viruses that have caused pandemics have been enveloped. Once the next pandemic happens, maybe we can quickly apply the ethanol vapor inhalation therapy to prevent or blah, 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 the disease, he explained. Again, I apologize. Certain words are still catchwords in regard to censorship. And we'll just leave it at that. Now, we're going to go back to the full study. It's kind of sad when you can't read through an actual science report that's detailed out without having to worry about being censored. Here goes the full study. Inactivation of influenza A virus at room temperature requires ethanol solutions more concentrated than 30%. However, at body temperature, influenza A virus is inactivated within 1 minute after exposure to 22.5% volume-to-volume ethanol solution. Interestingly, apical exposure of influenza A infected cells to 22.5% volume ethanol for 1 minute significantly reduced progeny virus yield over the course of 18 hours after exposure. Now, this next part is fun to read through. Now, you can see how the mind or the machinations of the researchers are going to see exactly how this can be incorporated if the results carry out to humans in the same light in a more trying setting. Let's put it that way. But it's kind of cute just to read through, so let us begin. In mice treated with ethanol vapor, blood alcohol concentrations decreased up to 0.05% and decreased rapidly in a few hours. Assuming a similar effect in humans, ethanol vapor inhalation may transiently raise blood alcohol to the Japanese legal limit, or above, I should say, for motor vehicle operation of 0.03%. See how the minds are working? But not in the United States, where the legal limit is 0.08%. These results suggest that short-term use of brief ethanol vapor inhalation treatment does not likely cause adverse side effects, including alcohol-related chronic diseases, although the systemic effects of long-term usage need to be evaluated. Now to the conclusion. In conclusion, ethanol vapor inhalation optimized to expose the respiratory tract to about 4% volume-to-volume ethanol gas can limit lethal influenza A virus respiratory infection without damaging the epithelial cells. Because various envelope viruses, including Sars CoV-2, are more susceptible to ethanol than influenza viruses, I highlighted that in quotes, but I'm going to read it to you one more time. Because various envelope viruses, including Sars CoV-2, are more susceptible to ethanol than influenza viruses, ethanol vapor inhalation may be effective against respiratory infection of these viruses, which enter through and bud from apical surface of the respiratory epithelium. Epithelium. All right. Future studies should evaluate the therapeutic effects of ethanol vapor inhalation against various respiratory infectious diseases, including Sars CoV-2 and the new up-and-coming avian influenza A virus. Now, I hope you understand as far as what I had to stick pretty much with the paradigm without interjecting any publisher bias or hyperbole, because it's very important, out of respect to the researchers, we stick exactly to what the study is written in the study itself without adding different dimensions or conjecture on how this can benefit other arenas. But it is just one of the most incredibly profound research articles I've read in a long time. Not so much because the detail of the study itself, but the impact is so incredible. If this pans out to be accurate in this manner against primarily envelope viruses and have the same impact against viruses maybe even weaker than influenza A virus and against ethanol, wow, that's incredible. We can't have this research like this go down the rabbit hole. And so I'm surprised that the media outlets did not cover it per se, but you and I are fortunate enough to, for whatever reason, come across this research, and hopefully we can propagate it at least or share with other individuals. Again, I am humbled by the research here. That is truly groundbreaking research, and as always, I am grateful that you watch, and thank you, and I'll see you all next week. Catch you next time. Bye.